Chemistry. First question is about the periodic table. So this question is about the periodic table and argon. What order did scientists use to arrange elements in the early periodic tables? What do you guys think? Let me get it up in the notes here. So it says here, they were organized by atomic weight. So the answer for the first one is the atomic weight of the element. So basically, back then, there was no concept of protons, neutrons, or electrons. So they had to use something that they didn't know about, which was basically mass. So that's why they used atomic weight, and then they arranged all the elements in terms of that. So that's the first answer. Next question. In early periodic tables, some elements were placed in wrong groups. Yep, well done, Lucy. It was wait. Mendeleev overcame some of these problems in his periodic table. Mendeleev did this by leaving, what's this? What did he leave? We got it here in the notes as well. So Mendeleev left gaps. So he left gaps for elements that had not been discovered. Next, what is the name of the group that contains argon? So you just need to look that up in the periodic table. Argon is on the last one. So I think I've got the modern periodic table here somewhere. Yeah, so if you zoom in here, you can see argon is over here. It's group 0. What do we call group 0? Group 0 is called the noble gases. So group 0 is the noble gases. Group 1 is the alkali metals, and group 7 are the halogens. Yep. Thank you. Okay, so next question. An atom of argon is represented by this. This should be a 40, by the way. It's been cut off a bit. That should be a 40. Determine the number of protons and the number of neutrons in one atom of argon. What do you guys think for that one? So the top numbers are called the mass numbers, and the bottom ones are called the atomic numbers. So we've got it here in the notes here. So mass number represents the number of neutrons plus protons. So that top number is neutrons plus protons. Bottom number is just the protons. So the number of protons is literally just 18. What about the number of neutrons? What do we need to do to work out the number of neutrons? We need to get both of these numbers. And it says here, to find the number of neutrons, subtract the atomic number from the mass number. So we get the atomic number, which is 40 minus 18, which gives 22. So the final answer is 22 for neutrons. Next question. Different atoms of argon are this and that. What is the name given to these different atoms of argon? So you can see here, they both have the same number of protons. They both have the same atomic number, which is 18. Every element has its own atomic number, which doesn't change. So argon is always 18. It's the top number that can change within an element. That's because the number of neutrons can change. So these two atoms have the same number of protons, different number of neutrons. Nope, the answer is not ions. So ions is when there's different numbers of electrons. So it's not ions. It's not fullerenes. Fullerenes is like, what is it? Graphite, diamond. It's an allotrope of carbon, basically. So that's nothing to do with argon. It's not a molecule either. It's an isotope. Yep, well done, Lucy. It's an isotope. The answer for this one is isotope. Good. What is the electronic structure of argon? So electron structures, you look at the bottom number. So remember I said that the bottom number is protons. It's also the number of electrons. Number of protons and electrons have to always be the same because the overall charge of an atom has to be neutral. So both of them need to always be equal. So this argon atom has 18 electrons. And the first shell needs to always have 2, second shell 8, third shell 8. If you add them all up, it gives you 18, doesn't it? So the answer has to be 288 because there's 18 electrons. Yeah, well done, guys. Everyone's getting it right. Why is argon unreactive? What would you say for that then? Any idea for that one? So that you need to think about its electron configuration here, 288. Why is it quite unreactive? Yep, Ranch, well done. Because it has a full outer shell. Yep, and well done. It's full outer shell. Let's see how many marks that is. Yep, that should be fine. 1 mark. Nothing else to say there. Well done, guys. Sodium. So this is another question about group 1 elements. Sodium reacts with chlorine to produce sodium chloride. Balance the equation here. How do we balance this? So sodium, chlorine, sodium, chlorine. We've got 1 sodium here, 2 chlorines here. We've got 1 sodium on the right, 1 chlorine on the right. We need them both to be the same. So, yep. Best thing to do is put a 2 here to make it 2 sodiums, and then put a 2 here to make it 2 sodiums and 2 chlorines. Now everything's 2, everything is balanced. Yep, well done, Abby. Next question. 4.6 grams of sodium reacts with chlorine to produce 11.7 grams of sodium chloride. What mass of chlorine reacted? What do you guys think you need to do here? Sodium plus chlorine forms sodium chloride. So we look at the masses, we've got 4.6 grams of sodium, and we've got 11.7 grams of, 11.7 grams of sodium chloride, isn't it? So then the answer is not 4.6. No. What do we need to do? So mass has to be conserved. So the total mass here of the reactants needs to be equal to the total mass of the products. So what you need to do to work out this one is you need to subtract the 2. You need to do 11.7 minus 4.6, which gives an answer of, yep, Mahania, well done. Answer is 7.1 grams. 7.1 grams. This question's not on the worksheet. It is. Is it on everyone else's worksheet? Yeah, it's the paper that I uploaded. Make sure you pick the one for the right date. Yeah, it is. Yeah, just make sure you pick the right one. A teacher puts hot... Yeah, check the date. Make sure it's the right one. It's the chemistry one for the 14th. A teacher puts hot sodium into a glass jar of chlorine. The changes seen before, during, and after this reaction were observed. Complete the sentences below. Yeah, thanks, guys. Sodium is a what solid? What color is sodium? Sodium's a metal. So usually what color is a metal? That would just be silver, isn't it? So we can just put silver. Chlorine is, what color is chlorine? Does anyone know that? That's something you need to memorize. I've got it here in the notes. That comes under the periodic table, group 7. Here we've got all the halogens and their appearance. So you can see here, chlorine is green. Yep, chlorine's green. Well done, Will. Chlorine is a green gas. The hot sodium burns with a... So sodium burns with a yellow flame, not a lilac flame, because that's potassium. Sodium is yellow. Lilac is for potassium. And then the product sodium chloride is a what solid? Sodium chloride is basically salt. It's like salt that you put in your food, right? So it's literally just a white solid. Okay, well done, guys. Next one. Sodium chloride is an ionic compound. Write the formula of the ions in sodium chloride. So we've got a sodium ion, we've got a chloride ion. The way to figure out which charge it has is by looking at the periodic table. Okay, so let me tell you. If it's group 1, is always +1. Group 2, always +2. Group 3, if you do come across group 3, I don't think that comes up much. It's +3. 4 and 5, you can't really make ions. So then we got group 6. Group 6 forms -2 ions. Group 7 forms -1 ions. Those are the ones to memorize. So based on that, let's look at our periodic table here. We got sodium. So sodium is here. That's group 1. So it's going to be plus. And then we've got chlorine here, which is in group 7. That's going to be -1, Cl minus. Yeah. If it's -1 or +1, you don't need to write the number 1. You can just leave it as it is. Next question. Potassium is more reactive than sodium. This is because potassium loses something more easily than sodium. Whenever it comes to reactivity, it's all to do with electrons. It's all to do how easily something loses electrons or gains electrons. So the answer is going to be an electron. So this is because potassium loses an electron more easily than sodium. How does the size of a potassium atom compare with the size of a sodium atom? For 2 marks, give a reason for your answer. So out of these two, which one is bigger? How do you guys think you can work that out? I'll show you where they are in the periodic table. I'll probably make it a bit easier to understand. Sodium is just above potassium in the periodic table. So they're both group 1. They both have 1 electron on the outer shell. But because one is in period 3 and the other one's period 4, then they're going to have different sizes. Potassium has a higher mass number. Yeah, it does have a higher mass number, but that doesn't tell you much about the size, difference in size. So potassium is definitely bigger. So we'll say that for 1 mark. Potassium is larger. Reason it's larger, yes, it does have a higher mass number. That means it has more electrons. If it has more electrons, it means it has more electron shells. Yeah, so that's the neutron. Sorry, that's the nucleus. And this would have, if it's potassium, for example, sorry, if it was sodium, it would be 281. But then for potassium, you would have a fourth shell in there because it's one below it. So nucleus in the middle, 2, then you've got 8, 8, and 1. So the reason for that is it has more electron shells. So would you say everything in period 1 is the same size? No, you wouldn't say everything. For GCSE, you can say that. They're not exactly the same size, but in GCSE, they won't really ask you about the same period. They always ask you different groups, but that's a good question. That is a good question. Okay. Let's move on to the next question. So this question is all about energy. So you can see here, this is what we call a reaction profile diagram. Reaction profile diagram. Label the activation energy. Where would you label the activation energy on this? So let me get it up on the notes while you guys try and figure it out. So it comes under energy changes, reaction profile diagrams. Here we go. So you can see here, activation energy is from the reactants all the way up to the top of the peak. So that's how we need to label it on our diagram. So we can do a dotted line here and then draw a straight line from here to here. That would be the activation energy. That's one mark. Okay, on to the next one. Determine the overall energy change for the reaction between hydrogen and oxygen shown in part A. Overall energy change. So you can see here in our notes, energy change is from the reactants down to the products. So let's do the same on our question. So reactants is here. And then products around there. So we got to get this number minus the bottom number to find the energy change. We want to find the difference between these two levels. So what's the top number? What's the bottom number? So 1, 2, 3, 4, 5 squares gives you 500. So that means each square gives you 100. Each square is 100. So that bottom one must be 300 kilojoules. And the top one, 1, 2, 3, 4, 5, 6, 7, 8, that makes it 800 kilojoules. So to find this value, you can just do 800 minus 300. 800 minus 300, which gives you 500 kilojoules of energy. Hope that makes sense. Let me know, guys, if there's something you don't understand, and I'll explain it again. So that gives you 2 marks doing that calculation. Okay, on to the next one. So this question is all about covalent bonding. So in covalent bonding, it's all about sharing electrons. sharing electrons. So first we need to figure out how many electrons each atom has. So the one on the left and the one on the right. You need to figure out how many atoms it has, how many electrons it has. So we can use the periodic table first to figure out how many electrons it has. Is oxygen. Oxygen is over here. Over here. You can see it's at 8 there. And on its outer shell, we're only showing the outer shell here. See, it says here that only the outer levels are being shown. So because it's in group 6, it means there are 6 outer shells. So we need to share 6 outer shell to make them both have 4 outer shells. So you want to share the 6 and give each one a full outer shell of 8 because that makes them more stable. That makes them more stable. So imagine the one on the left has 6 crosses. We're going to draw this one with crosses, and we're going to draw the other one with dots. 6 crosses, 6 dots. So the one on the left needs 2. It's got 6 right now. It needs 8 to become stable. So what it needs to do is it needs to share 2 electrons from the one on the right. So let's get 2 of these electrons. Let me get these 2 electrons and put them in the middle, because the left one needs 2. So it's basically sharing with the one on the right. The one on the right also needs 2, because remember that also has 6. So what that's going to do is it's going to share 2 electrons from the one on the left. So we're going to put 2 crosses in the middle. So the atom on the left has borrowed 2 electrons. The atom on the right has borrowed 2 electrons. Now we can simply just add all our remaining electrons. So see here on the left, we've got 1, 2, 3, 4 electrons. So 1, 2, 3, 4 electrons. And the one on the right has also got 4 electrons. So it's going to be 1, 2, 3, 4. Yeah, don't add 6 electrons here. That's a common mistake. People start adding more electrons here. This is what the answer should be. It should only be 6 crosses and 6 dots in the diagram. But now if you double check how many electrons there are, there's 1, 2, 3, 4, 5, 6, 7, 8. So the left one's stable. And the right one, 1, 2, 3, 4, 5, 6, 7, 8. That one's also stable. That's all good. So you can double check this in the notes here, because we've got basically all the ones, most of the common ones that come up in exams. Got a full list here. So hydrogen, chlorine, oxygen, nitrogen, hydrogen chloride, water and ammonia and methane. That's oxygen right there. These are the ones that come up most often. So you could either learn how to do it, or you could just memorize all the ones in the notes. Either way is fine. Okay, hope that makes sense. Let me know if there's any more questions. On to the next one. Okay, so we got a calculation here. Decomposition of hydrogen peroxide. Calculate the overall energy change for this reaction. So this is one of those bond energy calculations. So let me just get the notes up for that. Anyone know what to do here? What do we need to do in these types of calculations? So bond energy calculations. So we use this to find the energy change for a reaction. And this is the equation we need to use. Energy change is equal to bonds broken minus bonds formed. Bonds broken are basically all the bonds that you have in the reactants. Bonds formed are all the bonds that you have in the products. Okay, so let's look at this carefully. we've got this in the reactants. So let's look at our reactants first. How many bonds does this have? You can see here, it's got one O to O bond. Okay, so that's that value there. So 138. Let's cross that out. We've taken care of that bond. Then it's also got one OH here and one OH here. Let me know if this doesn't make sense, guys. So there's two OHs here. So let's look at our table. One OH is 463, but there's two OHs that we have, so we need to times that by 2. So 463 times by 2. Let me know if you do get the answer. If you're ahead of me and get the answer, tell me, just type it in the chat. So all of that is on the left side, but you also need to realize there's 2 of everything. So all of this is multiplied by 2. So 2 times all of that. That's now all of the reactant side done. Now we can look at the product side. 2 molecules in the product side. Do we multiply that whole number by 2? Yeah, we do. Well done, Will. You need to multiply by 2 because there's 2 of these molecules. That's why we multiply by 2. So we get all of that and 328. Is that your final answer? Not quite. Not quite. Try again. Next one. So what do we have here? We've got OH bond here, OH bond here. So we've got 2 OH bonds there. OH, we've already used this number. We're going to use it again. 2 of those. So we do 2 times 463. Branch got 706. No, not 706 either. Keep trying, guys. Someone's going to get it. So we got 2 OH bonds here, but remember, just like before, there's a 2 in front of this. So let's times all of that by 2 as well. So 2 times all of that. Let's put all of this in brackets because this is a separate calculation. And then let's add this thing here, O double bond. So here in the table, O double bond O is 496. So let's add that in as well. 496, close bracket. So this is the full calculation you need to do. So you can either do each one separately, or you can just do it all in your calculator in one go. Has anyone else got the answer to this? Or like the individual answers? What's everyone saying? Mahanya got -220. Yep, I think that's right. So that first part, the green part, everyone else check. Your answer should be -220. See if you can get to that. If you do just the left-hand part, you should get 2128. If you do the right-hand part, you should get 2348. And then subtract the 2 and you should get -220. Let me know if you guys are getting it. Is everyone else getting it now? Or if there's anything else that's not clear. So type in the numbers just as it is. Times that by 2. 2128. Yep, good. Tina's got it. Lucy's got it. Everyone else okay? Tell me if you need me to re-explain any of that. People do make mistakes in questions like this. I'll put that all down here. Okay, Will's got it as well. Okay, cool. So that's that. Let's carry on. On to the next one. Electrolysis, probably one of the worst topics in chemistry, one of the hardest topics in chemistry. Some metals are extracted from molten compounds using electrolysis. Why is electrolysis used to extract some metals? Anyone know that question? Anyone know the answer to that question? Why is electrolysis used to extract some metals? Because there's another way that we extract metals which we don't prefer as much. Yes, Rachel's got it. So look here, reactivity series, extraction of metals. Okay, so look at all these metals. Yep, Abby, well done. Minus 220. All these metals, there's two methods when you're extracting a metal. You can either use reduction using carbon, which is the preferred method. The reason that's the preferred method is because that's cheaper. All you need to do is you need to get the iron ore, the metal ore, and then combine it with carbon and heat it. Very easy to do. It's cheaper to do as well. Electrolysis, we do that for anything that's more reactive than carbon, because basically we can't reduce it using carbon unless it's less reactive than carbon. So these three metals, zinc, iron, and copper, hydrogen is not metal, zinc, iron, and copper, we can use reduction because it's less reactive than carbon, but all the ones above are more reactive than carbon, so you can't use it. So we use electrolysis instead. So you can say it's only 1 mark. So you can say metal is more reactive than carbon. So can't be extracted using reduction. Hope that makes sense. Aluminium is produced by electrolysis of a molten mixture. What two substances does the molten mixture contain? This is specifically for aluminium. It's going to need whatever compound you extract aluminium from. Let me show you in the notes. It'll come under electrolysis of molten compounds. Extraction of aluminium. There we go. Aluminium is found as aluminium oxide ore. So it's aluminium oxide is one of them. That's the thing that you're melting. And yeah, well done. Cryolite. Aluminium oxide and cryolite. Cryolite, they just use the cryolite to lower the melting temperature. Got it here. It's mixed with cryolite. It lowers the melting point of the aluminium oxide. It just makes the whole process cheaper. That's why we do it. Okay. This is probably the most confusing bit. Half equations. This part, they've kind of helped you, this question, but I think there must be another question later where they've just given you, they haven't given you any information. You just need to write the half equation. Actually, I think, I'm not sure if this paper has that actually. It might be next time's paper, next week's one. So yeah, let me show you how to write any half equation for electrolysis. Okay, so look here on the website, we've got 4 steps here. You want to write the ions going to the atoms. Then you want to check for any diatomic atoms. Then you want to balance, and then you want to add electrons. So yes, they've given you half of it. Let's assume they haven't given us this, and we just want to write the half equations from scratch for copper and chlorine. So like I said, this is like probably the hardest part of chemistry, paper 1. So first of all, yeah, people are getting the right answer. Well done. So first of all, what you want to do is write the ions to atoms. So for the top one, you want to go from ions, so Cu2 plus, to atoms, to Cu. Next step, check for diatomic atoms. Is copper diatomic? Copper is not diatomic. I've got the list of all the diatomic atoms here. Hydrogen, nitrogen, oxygen, and group 7. Copper does not come underneath that. So you don't need to do that. You don't need to make it diatomic. You don't need to add a 2 there. Next step is to balance. Do we need to balance this? No, we don't need to balance this. It's a 1-to-1 ratio, so that's fine. And then you just need to add electrons. Electrons need to go on the right side, on the correct side. So I've got it here. For anodes, electrodes go on the right. For cathodes, electrodes go on the left. Electrons go on the left. This is the negative electrode we're talking about. Negative electrode is the cathode. Positive electrode is the anode. So for anodes, the electrons go on the right. So we need to put a plus E minus on the right. We'll come back to that in a second. We're doing the cathode right now. Cathodes, it goes on the left. So we need to put plus 2E minus. The reason you need plus 2E minus is because this is 2 plus. You want to balance that. And on the right, we had the copper. So we put a Cu there. Let me follow the same steps for chlorine. So let's go back to our steps again. Write ions to atoms first. So ions, Cl minus to atoms, Cl, arrow. Next step, check for diatomic atoms. Is chlorine diatomic? Yes, it is. Here you can see it in the table. I've got a list. Any group 7 element is always diatomic. So let's put this 2 here to show that it's diatomic. Next step is to balance. So if we've got a 2 on the right hand side, we need 2 chlorines on the left. Let's put a 2 there. Now, final step, add electrons. We need to put electrons on the correct side. This time we're doing the anode. For anodes, electrons go on the right. So that means it's going to be on this side here. Make sure you add the correct number of electrons. There's 2 chlorines. Each chlorine is losing 1 electron. So in total, we've got 2E minus here. So that's how to write a half equation from scratch. So the answer here would be Cl2 plus 2E minus. Yeah. If that, yeah. So if you want to practice this more, just go on the website. Look, I've got this whole table here with loads of different examples where you can write the half equation for the anode and for the cathode. So literally cover up everything apart from the left column and then try and write the half equations for each one. Try and follow those steps. So I've got the 4 steps here. Practice, practice, practice. If it's confusing for you, then just keep practicing that. Okay. Any questions, guys? Let me know. Well, I'll go on to the next one because I know this is a difficult topic. So, next question. Figure 1 shows the apparatus a student used to electrolyze copper chloride solution. Student measured the mass of copper deposited on the negative electrode after 60 minutes. Compared the mass deposited with the expected value. So just 2 reasons why the mass deposited was different from the expected value. Lucy asks, is all group 7 diatomic? Yes, it is. All of group 7 is diatomic. So everything in this table, if I can find it. Yeah, these are the ones that you need to know for GCSE. So hydrogen, nitrogen, oxygen, all of group 7, all diatomic. So just 2 reasons why the mass deposited was different from the expected value. So basically you're carrying out electrolysis and you're expecting a certain mass, but then when you actually weigh these electrodes, because the mass of these electrodes will increase when electrolysis occurs because copper is basically building up. So imagine this electrolysis occurring. the mass of this increases because it's gaining copper atoms. So it gets heavier. So they take it out and they weigh it. And they're saying that when they weigh it, it's different to the value that they expected. What is the reason for that? So think of like ways that errors could happen during this experiment. So remember, this whole thing's in solution. So one thing could be the electrode's not dry. So imagine you take it out of the solution and you weigh it straight away. It still has a little bit of mass from the water. So that's going to add mass to it. It's going to make it higher than expected. So that's one thing you could say. The electrode is not dry. Another thing you could say, compare. So another reason why the mass could be different is, anyone got anything? No, no one's got anything. You could say that there's impurities maybe. So that solution, the copper chloride solution, might not be purely copper chloride. It could be something else as well. So you could say copper chloride is not pure. All right, on to the next one. Figure 2 shows the expected mass of copper produced each minute. Determine the expected mass of copper after 24 hours. What do you guys think we need to do here? So look at this. We've got a graph of how the mass of the copper. So remember, the copper electrode is gaining mass. It starts off here. It's gaining mass. And we want to work out what would it be after 24 hours. We've only got the time up to about, what, 33 minutes, isn't it? So what's a good way of working this out? I'd say, look at the reading at 30 minutes. So that's half an hour. From that reading, you can probably work out what 24 hours would be. So that's around here, isn't it? So we got to work out what this reading is here. So each square is 1, 2, 3. There's 5 squares in between 5 and 6. So that means each square is 0.2. So that reading is 5.4 because there's 2 squares on it. So after 30 minutes, it gains 5.4 grams. We want to work out how much it will form after 24 hours. So how many 30 minutes are there in 24 hours? What would we need to do? So you could work out how many grams it is in 1 hour, which is basically 60 minutes, and then work out how much it is in 24 hours. So how do you get from 30 to 1 hour? Double it. Yep. So first thing you can do is double it. So 5.4 times by 2. Then to get 24 hours times by 24. So times by 2 times by 24. Anyone got an answer? So someone got 259. Yep, 259 is correct. Well done. So you do 5.4 times by 2 times by 24, and you get 259. Lucy, you got 2592. I think you must have multiplied by 10 somewhere. 259 is good. Okay, let's move on to the next one. Silver nitrate solution is electrolyzed. Figure 3 shows the change in mass of negative electrode over 10 hours. Determine the mass of the negative electrode at the start of the experiment. Determine the mass of the negative electrode at the start of the experiment. So that is literally going to be the first reading. Can anyone tell me what that reading is? Look carefully where it is. It's not on a specific line. It's in between. It's in between this line and this line. So what would that reading be? So that's 0. There's 10 squares in between. This is going to trip up a lot of people here. So that's divided by 5. So each 2 squares is going to be 1. So 1, 2, 3, 4, 5. Yes, well done, Lucy. It's going to be 4.75 because that's 4. So that means this is 4.5. That's 5. It's in between 4.5 and 5, which means it's 4.75. Just got to read it carefully. Most people, I'd say, would put 4.5 there. That wouldn't be right. 4.75 grams. Calculate the gradient of the line in figure 3. Okay, so gradient is change in y over change in x. Change in y over change in x. Let's see how many questions we've got left. Okay. So we've got that 4.75 here. We just worked that out, 4.75. Let's work out the gradient using these values. So change in y is this number here. Change in x is this number here. So let's try and figure out what these numbers are. So I think the bottom number is easy to work out because that's literally 10. This goes from 0 to 10. So this length here is 10. Then the height of this, so remember what I said when I put the numbers before, that's 1. Each 2 squares, that's 2. So that means 4 squares is 2, isn't it? Let's count how many squares there are here. From here to around there. I would say that's 1, 2, 1, 2, 3, 4 squares. There's 4 squares. So that would make the height of this 2 because 4 squares here was also 2. Hope that makes sense. Tell me if that doesn't make sense. I'll explain that again. So the height is 2. So the height of that triangle is also 2. So what we want to do is change in y over change in x. So when you're doing this in an exam, guys, try and actually draw this triangle because you get method marks for that. So don't just try and do it by eye. Literally get a ruler, draw a horizontal line, draw a vertical line, just to show the examiner that you actually know what you're doing. Even if you make a mistake on the next bit, you'll still get some marks. So gradient is equal to 2 over 10, which gives you 0.2. So the gradient is 0.2. It's asking for units. Units. So remember, this gradient is change in y over change in x. The y is in grams. The x is in hours. Change in y over change in x. So it's grams per hour. The unit is grams per hour. Okay, so sometimes you might just need to figure out the units. If they don't give you the units, it might not be one that you learn, but you might need to figure it out. So here you just use the gradient, the fact that it's change in y over change in x, and you can use that to figure out that it is grams per hour. Okay, on to the last question. Sodium reacts with chlorine. What is the balanced equation for the reaction? Sodium plus chlorine. I've got this in the notes as well. This comes under group 1. Let me know what you think the answer is. Here we go. Sodium plus chlorine, 2Na plus Cl2 goes to 2NaCl. That's the answer there. Hot sodium is put into a glass jar of chlorine. Yeah, third option. Well done. Describe the observations made before, during, and after the reaction. Okay, so hot sodium is put into a glass. So before the reaction, what are you going to see? So we've mentioned this already. We've mentioned that sodium is silver and chlorine is green. Yeah, so mention that. That's what's going to be observed before. So silver, solid, and green gas. Then during the reaction, what's going to happen? The green gas is going to disappear, isn't it? Because at the end, all this green gas is basically being used up in the reaction. So that green gas is going to disappear. And then what you're left with is sodium chloride. And I told you how it looks like earlier in the live. I told you it's a white solid. It's salt, isn't it? So a white solid is produced. And that should be good for 3 marks. And then we're on the last page. Explain why sodium is less reactive than potassium. Okay, so we got 4 marks here. We've got 6 marks here. Why is sodium less reactive than potassium? Let me show you here. So here we got lithium and sodium, but it's pretty much the same explanation. Remember earlier I told you that potassium was bigger than sodium. So because it's bigger than sodium, so if we had sodium here, there'll be more electron shells. 3 electron shells. So that outer electron is going to be around here. But for potassium, 1, 2, 3, 4. So for potassium, the electron is going to be all the way out here. Think about the attraction here. The nucleus is positively charged. The electron is negatively charged. Nucleus is positively charged. Electron is negatively charged. So that means when you think about the attraction, this one, the sodium, has more attraction. So there's more attraction between the nucleus and the electron. And this one has less attraction. So that means for potassium, it's more reactive because it's much easier to lose this electron. Because there's less attraction, it's much easier to knock that off. So when these react, when the group 1 elements react, they lose an electron. And because the outer electron is further from the nucleus, there's less attraction, meaning it's more reactive. Those are all the points that you need to make. So let's try and get 4 marks here. So 1 mark is to say, so it's asking specifically about sodium. So you say sodium has fewer shells as it is smaller. So I'm talking about this one here, right? So I'm basically talking about the opposite of what I said. So if it's smaller, there's more attraction. More attraction between the outer shell and the nucleus as it is closer. So it's closer to the nucleus, so there's more attraction. That's 2 marks. So we've got 1 mark here, we've got 2 marks here. Therefore, less energy. Sorry, more energy. More energy is needed to lose the electron. And that's the 4th mark. Anyone got any questions on that? Let me know. Now look at the 6th marker we got here. Compare the structure of sodium chloride and hydrogen chloride. We need to identify what's the difference in bonding between those two. So they both have different bonding. Let's go into our bonding notes and see. So sodium chloride is between a metal and a non-metal. Ionic bonding is metal and a non-metal. So sodium's a metal, chlorine is a non-metal. So that makes this ionic. Here we got hydrogen, which is a non-metal, and chlorine, which is a non-metal. That is covalent. So if you go to covalent notes, you should find it somewhere. Yeah, occurs between non-metals. So we need to describe the differences between the two. So what are some of the things we can say? So let me do 2 paragraphs here. So for sodium chloride and then for hydrogen chloride. So first thing we can say is it's ionic bonding. Hydrogen chloride is covalent bonding. You can mention that it's a metal and a non-metal. This is 2 non-metals. Anything else you can mention? Let me know if there's anything else you can think of about ionic bonding that you know. So ionic bonding is it occurs between oppositely charged ions. How do the oppositely charged ions form? When there's a transfer of electrons between the atoms. For HCl, so it's covalent. That's because there's a sharing of electrons. That's another thing you say. There's quite a lot of things you can say to get marks here. Anyone got anything else we can say? Differences between ionic and covalent. Hydrogen chloride, you could also say, is a simple molecular or a molecular substance. You could talk about the forces between the two. Ionic bonding has electrostatic forces of attraction between the ions. What about simple molecular substances? What type of forces do they have? Should have used a different color. So ionic bonding has electrostatic attraction between the ions, whereas simple molecular has intermolecular. Not getting a lot of replies for this question. Is it because it's a bit more difficult? All of this is in the notes, guys. So if you're struggling with bonding, just go through all of it. Go through the notes. Try out all the questions on it as well. Check out the spec points. Make sure you know everything in it. Carry on practicing after this if you're struggling. So intermolecular forces between the molecules.